Okay, this is a fun problem. This is 669 out of the CPM textbook, and it's asking, are these two expressions equivalent? I'm going to do these in 3 different ways and see whichever way makes the most sense for you and works. The first one is I've got just 12 of something minus 2, and here I have 3 4x minus 2's. So I'm just going to draw out what that looks like. So I've got 3 4x minus 2's. Here's a 4x minus 2. Here is a 4x minus 2. Here is a 4x minus 2. I have 3 4x minus 2's. The other way that looks is if you draw a generic rectangle. Here I have 3 rows of 4x minus 2. So here I would have 12 x's. Here's 4x, 4x, and 4x. And then here I would have 3 negative 2's. So negative 2, negative 4, negative 6. If I add them together, I see that I get 12x, which is the same, but it's minus 6, not minus 2. These are not equivalent. I can tell that here. If I add up all my 4x's, I get 12x's. If I add up all my negative 2's, I get negative 6. This expression is equivalent to 12x minus 6. The other way, if you weren't sure and were really stuck on this problem, if there's variables and they're asking you, are they equal, are they equivalent, or which one is greater? This doesn't always work, but if not a bad strategy is just if you're really stuck, plug in a number for x. Just try out, well, what if x was 1? What if it was 1? Are they equal then? This doesn't always work, but if you, let me move this guy. Down and away. If I do that, if I just say x is 1, this becomes 4 1's minus 2. And then I have 3 of those, so this becomes 4 minus 2, which is 2. And 3 2's is 6. And for here, I'd plug in, I'd have 12 1's minus 2. This becomes 12 minus 2, which is 8. I can see right from there that these are not equivalent expressions. If somehow I got really lucky and the expression did work for 1, that doesn't necessarily prove that these are equivalent. Which is kind of a trip. It proves that they were equivalent from when x was 1. So I do want to try something else, maybe like x was 2. And if I plugged in 2 for x and still got that they were equal, then I would feel pretty confident to say that the two expressions were equivalent. But since that I got that for when x was 1 that they weren't equal, they are not equivalent expressions. They would be equivalent if I got for whatever I plugged in for x, I would get out the same answer, the same number in return.